So our goal here is to calculate the portfolio standard deviation without using all this returns directly. So it's like we don't see them. Actually, we need them for calculating the variance and the covariance matrix, but to get standard deviation, we will just use the matrix only. All right, so how exactly are we going to do it? So let me first create the title, okay? And you can see I got 4 stocks, and I copy and paste again, but this time I'm going to paste a special, and I do only transpose. Okay, and then I will just eliminate all the border lines. And right here, you will see that it's a 4x4 matrix, so I can do covariance, that kind of calculation, covar, and then I do a comma, and then A by itself. The covariance between A and self is this one, but I should use a covariance S, because this is only a sample. Okay, covar is the same as covariance population, covariance P, but I should use a covariance S. The thing is, I don't want to repeat it, the same covariance S calculation 16 times. You see, I got 16 rows to fill out. So I will need to rely on the very basic formula of a covariance calculation. So let's see, I'm going to do this. All right, copy, and in this area, I'm going to do paste special, and then transpose again. All right, so let me just eliminate all this borderline and add a borderline here. So what I will do is to use this A's return. I'm sorry, this expected return should also be transposed to here. So what I will do is to get each of the return here coupled with the return here. So you can see row A, column A to get A's variance, and row A, column B to get the covariance between A and B, row A and covariance and column C to get the covariance between A and C, and so on. Okay, and this is exactly what I lectured. I'm going to use a row multiplied by a column in order to get one single number as output instead of a column multiplied by a row. That's gonna mess things up. Okay, so that's why I need to get the returns in a row and then multiply by the returns in the column. So the thing is, to do that, it's not the returns by itself, it should be the deviations. So that means each return will be subtracted by the expected return to get the deviation. So you have the deviation for all the returns here, and then the deviation for all the returns here multiplied together. And you're gonna sum them up. That means you're gonna use a sum product function, and then the whole thing divided by 4. 4 is 5 minus 1, you get 5 returns. So statistically, if you need a sample, if you need a standard deviation based on a sample, you should use n minus 1. So 5 minus 1 gives you 4. So to do that calculation, I will do this. So I will use the whole areas here minus the expected return. All right, so that's all the rows. And I will need to perform matrix multiplication. Okay, this whole thing, I will put them in a parenthesis. Multiply, okay, sorry. Then there's a whole area, all the columns minus the expected to get all your deviation. Maybe I don't need this, sorry. I don't need a parenthesis here. Alright, and then the whole thing divided by 4. 4 is not 4x4 matrix, it's not 4 stocks, it is a 5 month minus 1, n minus 1, and then Control Shift Enter. So this is your variance covariance matrix. Well, the thing is, let me repeat doing that. So Control Z, undo it. when you are doing that calculation, make sure you first select the entire area 4x4 matrix. Okay, make sure of that, and then use equal sign. All right, you can see all 4x4 matrix are selected, and then equal sign, and mult, and then all the rows of returns minus expected, then all the columns, the returns in columns minus the expected. Okay, you can see if I hit Control Shift Enter, then all the report will be generated. But what I forgot is to divide it by 4. Okay, let me redo it. Okay, all the rows minus the expected, comma, all the columns of returns minus expected. So it's a deviation multiplied by the deviation divided by 4. So that's how we calculate the variance covariance matrix in the simplest fashion. Okay, or you can do this if you prefer a more sophisticated way. So let me delete that. You can just do transpose. All right, you do mult, and then you're gonna transpose whatever I did here. So you see I copy this area of cells and transpose in this area, but this time I'm not going to do a copy paste. Instead, I will just do it. Okay, the columns returns minus the expected, the deviation in columns, and I transpose it. So that's the same as I copy and paste the transposed way to have this. All right, and then the whole thing, the columns again minus the deviation, Control Shift down arrow. All right, so what I forgot, sorry, I keep forgetting that. So this is pretty important to divide by 4. Transpose this guy minus the expected, close parentheses, and then these guys minus the expected, the whole thing divided by 4. It's the same. All right. So now after I got this variance covariance matrix, so what should I do? I should use all the weights multiplied by the variance covariance matrix, and then multiply all the weights. But be careful, you should use the row multiplied by the matrix, and after that you're going to get a row, and multiply by the column, you're going to get one single number. All right, it's like let me give an example. So let's say if I have a 1, 2 as one matrix, okay, and then I have 1, 2, 3, 4 as another matrix, a 4x4 matrix, 2x2 matrix to have 4 cells. Then I should use the matrix multiplication to get a result. So I can just use a 4x4 matrix to show you my point. I mult, and then the row here times the matrix here. Control Shift down. You can see I got the replicate. Okay, I got duplicate of answers. So that means they are pretty unnecessary. So I only need a row to show my answers. Okay, so the bottom line is the basic linear algebra is telling us if you use a row multiplied by a matrix with the same number of columns, then you would get a row as the answer. So how do I get 7? It's 1 times 1 plus 2 times 3. How do I get 10? It's 1 times 2 plus 2 times 4. And after that, I'm going to use 1, 2, this column. So I will do another matrix multiplication and mult. So you can see that the result is going to be one single number. Oops. Select too many rows. Okay. All right. So back to the implication in this portfolio risk analysis. So I will ask you to do this portfolio risk or standard deviation. It's the same. All right. And then you will need to calculate the portfolio risk instead of getting all of this areas. So basically, you don't need all this returns. Okay, you don't need to see all these returns. You don't have to calculate them, the portfolio returns on a monthly level. You just need to utilize the the variance covariance matrix. Okay, so I will use LMULT times, all right, comma, then the variance covariance matrix. Okay, so this is going to give me a whole row as a number, and then I will need to perform another round of LMULT matrix multiplication, and this time I will use the weight column. But you see that the weights here are located in a row, so I will need to do transpose. I'm going to transpose that row into a column so I can perform my calculation. So after the transpose, don't forget to put a big set of parentheses outside, and then you can do Control-Shift-Enter. But there are two things I want you to add. Number one, you are going to drag it all the way down. You want the returns to be, the weights to be shifted, but you don't want the matrix to be shifted. Therefore, you have to lock this variance covariance matrix. And number two, this calculation, the entire area here for the 4 stocks, you will get what you get is called a variance, and you need to get the square root of the variance in order to get the standard deviation. And number 3, if you want to close it, don't just hit enter. You should do Control-Shift-Enter, and then drag it all the way down. So you will see that these numbers are the same as the numbers here, just in a transposed format, but they are calculated not based on calculating the monthly return or the historical return of each period for the portfolio, but based on the variance covariance matrix, which could be done more easily. And in this practice, you may not find the variance covariance matrix. This method is easier. It's because you have very limited stocks. But if you have, like I said before, 20 or 30 stocks, then this method will be the most efficient one. Okay, and that basically concludes this exercise. So in this exercise, you learn how to get to the portfolio standard deviation, and based on different weights, and you can optimize the portfolio by minimizing the portfolio risk by changing the weights of the stocks. Just like this one is more complicated. You have different portfolios. They all have a minimized risk level, but they have different returns. All right, and you can get that minimization. Okay, you can calculate the portfolio risk by using the variance covariance matrix, and eventually you know how to create a chart. It's called efficient frontier. So that basically is the best you can do under different set of goals for returns. So if the return is 9%, then this is how much you can get for the risk. If the return is 10%, this is the lowest risk you can get. So it's a little bit counterintuitive. Normally in the world of investment, we want to accept a certain level of a risk to maximize the return. But it is more like you lock in your return target first and then try to minimize the risk. So that's how we do portfolio management.